This is Semester 2, Chapter 11, Exam Review. We're looking for the mean and the range of this data set. Well, we can take our graphing calculator, hit Stat, go to Edit. If you go up to your lists and hit Clear, get rid of all your data. We'll type in 57, 84, 63, we can hit Stat, over to Calc. I put the information in list number 1, so I have an average of 72. We're looking for a mean and a range. Well, the mean would be 73.5, and my range would be the maximum minus the minimum. So 84 minus 57, which is going to be 27. The data set has a price of 14 mountain bikes. What is the mean? What is the average price? Another way we can do that is to type in the actual prices. Just want to be sure you type them in correctly. And we divide by the number of bicycles, which was 14. So we have $282. The data set below gives a price of 14 mountain bikes. What is the mean, which means the average? I got a different price. Let's check our data. 850, 270, 150. Oh, there it is. Just as I said it, I probably typed it in wrong. That's the advantage of a multiple choice test. The mean of a data set is 25. Each value of the data set is multiplied by 5. What is the new mean? Well, when we multiply all the values of a data set by the same amount, think about what happens to the data. The smallest one gets bigger, the largest one gets bigger. That means the mean is going to get bigger by that same multiple. So if the mean was 25, we're going to times that by that multiple of 5, and it's going to be 125 is the new mean. Which of the following summary statistic remains unchanged when a constant value is added? If every value goes up by the same amount, the mean is going to go up. The range, the difference between the numbers shouldn't change. The distance between the numbers should stay the same. The median is going to get larger and the mode would be getting larger. So the range is the one that is unchanged. The following data gives numbers of pages in 5 high school textbooks, which is a false statement. There is no mode. No numbers are being repeated, so that's true. The range is 384, so we take this largest number, subtract the smallest number, that's 384. So now we need to talk about and figure out what the mean is. So we got our average of 569. The mean is 569. That is true also. The mean is greater than the median. Well, the median is when you cross off the lowest and the largest and smallest, largest and smallest. In this case, the mean is greater. No, the mean was smaller than the median. Describe what happens to a mean and the standard deviation of a data set if 7 points are added to each value of a data set. The standard deviation, that explains how the data is spread out. If you add the same amount to every piece of the data set, they're still spread out the same way. They're bigger numbers, but they're still spread out the same way. The mean would get bigger, and it would get bigger by that 7 points. The mean would increase, and the standard deviation would increase. This part isn't true. The mean would decrease. No, not if you're adding values. The mean would increase, and the standard deviation would stay the same. That's what I think is going to be right. The mean would stay the same, and the standard deviation would stay the same. C. Given an approximately normal distribution, what percent of the data would we expect to be between the mean and 2 standard deviations below the mean? So if that's our mean, our x bar, that's 13%. That's actually, sorry, that's 34%. That's 13%. So that's 13.5 actually. So that's our 47 if you want it to be below the mean. If it would say, what's the percent of the data that is within 2 standard deviations of the mean, that's when we would have said 95%. That would be below and above. This just says below. The winning scores for the first 10 football games are given. What is the standard deviation? We can do the standard deviation by hand, or we can use our calculator. So we go to Stat, go to Edit. We'll clear the data by hitting Clear, not Delete. Type in our data, over to Stat, and our standard deviation is the one with sigma, so it's 4.28. Letter D. A normal distribution has a mean of 51 and a standard deviation of 3. So that's 51. One standard deviation up would be 54, then 57. Down would be 3 less, which is 48, then 45, and so forth. If we want to know how much is at most 48, that would be 13.5, 2.35, and 0.15. So we're going to turn 0.15% into a decimal. We'll turn 2.35% into a decimal. And we'll turn 13.5% into a decimal. We get 16.16. What is the percent of the area under a normal curve that is represented by the shaded region? It looks like our shaded region goes to 3 standard deviations. So here would be 34, 34, 13.5, 2.35. Thirty-four, 13.5, and 2.35. We get 83.85. And those are percentage values, so it's percent. Rachel scored 88 on her math test. The average score was 79.3. Standard deviation 7.5. What is her z-score? There's the formula for a z-score. So her score was 88 minus the average over the standard deviation. Divided by 7.5 gives us a z-score of 1.16. A normal distribution has a mean of 64 and a standard deviation of 7. So we have a mean of 64, standard deviation of 7. We want to know what percent of the data is below 54. If you subtract 7, we get 57. Subtract 7 again, we get 50. So this 54 is somewhere in between. That's where the 54 would be. So we can't use the 13 or the 34 or the 2.34. We have to get a z-score. Since it's in between the bars, we have to get our z-score. So we get negative because it's less than the average, 1.42. This would be 1 standard deviation and more. So that's what that negative 1.42 means. So from here we would look at our table values to see what the z value was. So that would be negative 1.43, and looking at our standard normal table, that would come out to have the probability that x is less than 54 is the same thing as the probability a z-score is less than negative 1.43, and that is 0.0764. You need to use the table that was provided with your notes. If you use the table that goes to the hundredth spot, you can get this much detail. The annual per person consumption of apples is 16 pounds with a standard deviation of 4. Find the z-score for consuming 22 pounds. So it looks like we have a standard deviation of 1.5, or a z-score of 1.5. We know it's going to be positive because your consumption was bigger than the average. What is the probability that a randomly selected person in the United States consumes less than that? So what's the probability that a person consumes less than 22? That's the same thing as a z-score less than 1.5. So going to your table, you'll notice that we get 0.9392. 0.9332. 93% of the people eat less than 22 pounds. What is the probability that a randomly selected person consumes apples between 18 and 24 pounds? There's the 16. One standard deviation up is 20. Two standard deviations up is 24. We know that 18 is in here somewhere. So to determine what percentage of the data is in between that amount, we know that this is 13.5, so this is going to be more than 13.5, but we can't tell by looking at this. We're going to need to know what percentage of the data is less than 24. Well, I can do that by looking at a chart or by doing a z-score, your choice. Looking at it in terms of a z-score, two is going to be 0.9772. Then we're going to look at, that would be 97% of the people are below 24. But we don't want to go below forever. We just want to go until we get to 18. So now we're going to subtract away everything below 18. So we need to find the z-score 15, which we're going to get 0.6915. We still know it's above 0.5 because it's more than the average. Now, to figure out what's in between these two, we subtract our values. So the probability that we have a value greater than 18 but less than 24 is going to be this 0.2857.